Hello everyone, and this is Group 6, and our topic is Indoor Air Quality Monitoring System. I'm Liu Hong Irvin. So let me talk about the rundown of this demonstration. And firstly, Wong-Tachi will talk about the initialization of the system, about the LCD and serial communication, and then he will demonstrate the monitoring the gas and the corresponding output, which is about the range of data and the output in LCD and serial field. Then Chen Feng will demonstrate how to adjust the brightness of the system by turning clockwise and anti-clockwise of the variables resistor, and then he will demonstrate how to trigger the alarm system on and off. Then I will demonstrate how to monitor the temperature and the corresponding output, about the range of the data and the output in LCD and the serial field. Then Chen Feng will talk about the mobile application of our system, which is the interface for the customer points of view. And then I would like to talk about the mobile application on the interface for the company's owner's points of view. And finally, the Watashi will talk about the web server of our system, which is about the XAMPP control panel, the website, and the Arduino IDE. And after we make our own video, I would combine and do the video editing.
Hello, here is Wong-Tachi. My student number is 54849652, and I will introduce the whole system simply. Actually, it's about the initialization of the system. The system including the Arduino, the LCD boxes with a potentiometer, a alarm, a temperature sensor, and a gas sensor here. And I will introduce how to initialize the system first. To initialize the system with the LCD box, we need to include a library file which used for the LCD connection. And here you can see that which link in the Arduino is connected to which link in the LCD box. And we have to set the serial number of the LCD to 9600 to approve the data transmission at this baud rate. And next we have to initialize the LCD. Use this code just to begin the LCD and let it work. And here, after it works, it will print welcome to the air quality monitor. And I will show the simulation now. Yeah, you can see that welcome to the air quality monitor, and it will start recording the air quality and the temperature. Yeah, just like that. And this is the end of the initialization introduction. Thank you. Here is Wong-Tachi again, and I would like to introduce how to monitor the gas and the corresponding output of the gas sensor, just like the range of the data and how it's output here. And I will start the simulation now. After the initialization of this whole system, it will show the air quality and the temperature of the system now, how it detects. And just like here, you can see that if the dark air is out is go away from the gas sensor, it will show as flash air, and the air quality is here. The range is around 300 something to 700 something, and when I move the dark air close to the sensor, it will show that, yeah, here the air quality is around 700 something, and it will show very poor air here. And how to detect it? The gas sensor is connect to the connect to the A0 port of the Arduino, and here this coding. This is used to read the analog read from the A0 port, and it will show out what is the analog read, and just here is how the data is detected. And about the monitoring the gas sensor is end here. Thank you.
The brightness of the LCD is variable. For the LCD screen we choose, it has a 16-pin interface, and one of the pin is a contrast voltage pin, which is denoted as V0. And the difference between the source voltage and the contrast voltage would determine the contrast level or the brightness of the LCD screen. And as you can see, we have attached the VO pin with the variable resistor, and if we turn the pointer clockwise, it will increase the resistance, so increase the voltage difference, and thus increase the contrast level of the LCD. For the alarm system, it will trigger when the air quality is very poor or temperature is not in the normal range. The Arduino will then send a digital high to pin 10, which is connected to both the LED and the buzzer. And you can see here. Okay. When the system detects poor air, then it will trigger the alarm system. And both of the LED and the buzzer will turn off once the temperature and the air quality are returned to the normal range.
So this is the circuit view of our design, and I would like to demonstrate how to monitor the temperature at this corresponding output. And first of all, we are using the TMP36 in Tinkercad to use as a temperature sensor. And this first pin is connected to the power supply 5 volts, and the second pin is connected to the V out, and this is the analog A1, which is for the analog read function to collect the temperature data. And the third pin is the ground node, which connects to the ground. And let's start the simulation. And as we don't have the real temperature just like the real life, and we can just drag the circle to adjust the temperature, and we remain in the normal temperature, which is larger than 15 degrees Celsius and smaller than 34 degrees Celsius. And please wait. And the temperature 24 degrees Celsius is shown here, which is the normal temperature next stage shown here. And the alarm won't be on, and send data to cloud. And then we adjust to the higher temperature, which is not the normal level. And then too hot, message too hot will be shown here, and the alarm is on now. And if we remain the temperature in the around 47 degrees Celsius, and the message too hot will remain here, and the alarm will be on. And then we turn it back to the normal temperature. and the data shown in here, and the alarm is off now, and we return to the normal temperature. So we now turn to the lower temperature, which is less than the 15 degrees Celsius. So the temperature here is 8 degrees Celsius, and the message to call will be shown here, and the alarm is on once again. And if we don't adjust it back to the normal level, and the message will be still too cold and the alarm will be still on, and then we finally turn it back to around 28 degrees Celsius. So the temperature is normal here, and the alarm is off now, and the normal temperature is shown here. And all of the process we go through will be shown in the serial wheel here, which is identical to the LCD display. So this is the end. Thank you.
This is the demo for the app design for customer interface. As you could see, there are only 3 information for each branch, including the branch number, the branch location, and the recorded air quality. It is because we want to make the interface as simple as possible. And you can see the user are not allowed to modify the record since they are only the customer but not the company. And if the user want to see more information about the branch, they can click on the branch and more information will come out. For example, the phone number, the manager name, and the temperature, etc. If a user want to search a particular branch, they could search the branch number or branch location. For example, searching 106, and then I can get a branch which branch number is 106. And the app would have some supporting functions, for example, the feedback and share assistant, etc.
So hello once again, and I'm Liu Xiaohong Irvin, and I would like to demonstrate on the mobile applications of our design on the interface for the company owner's point of view, and which comparing to the interface for the customer point of view, which that interface is focusing on the general informations of the company, such as the company location or the phone number or the manager name, etc. Which this interface will be more focusing on the detailed data of the air quality data and the temperature data for the company's owners to check the data and try to improve the indoor air quality conditions. And so after they open this app, and you can see the app name, which is too long. It actually is the indoor air quality monitoring app, and the app icon is shown at the left. Yeah, and after they choose their own company, for example, company A first, and they can view the graph present, and they can, for example, the business hour of company A would be 1 p.m. to 12 p.m. So they can see the whole set of data of the in the business hours, and also after, if they click here the data, they can see the data in the table format, and which is shown in a detailed way. And for example, they click on it, will show the specific time, the air quality data, and the temperature data. And also we'll have the advice button here. After they click on it, you will see about the overall conditions and the advice. And for example, you can click the specific branch. For example, for company A, and obviously the air quality data is generally lower than 400, which is at a good level. So the advice would be maintain these conditions, the current conditions. So for the temperature is the same, because they're generally within the 15 degrees Celsius and the 34 degrees Celsius, which is at a normal range. So the advice would be maintain the indoor temperature. So, and then we can choose the other company, for example company B. So the business hour would be 10 a.m. to 12 p.m. and obviously you can see the data will be much higher than 400 most of the time. So you can check the full set of data and the data column and click on the F5s, which this time for the company B, the air quality value is higher than 400 and even higher than 500 almost most of the time. So which is at a poor and a very poor level. So the advice would be indoor the air cleaner or seek the suggestion from the experts. Yep. So this is the case, and check the company C here, and which is you can see the air quality data is generally lower than 400. And you check the data. However, the temperature is a little bit high in a specific time. You can check the F5s here. So for the air quality data is normal level, maintain the current situation. But for the temperature value is higher than 34 degrees Celsius at 1 p.m. to 3 p.m. which is at the stage will be too hot. So we would like to the advice would be turn on or turn high of the air conditioners at this specific time zone. Okay, so also the users can provide us their useful feedback to us. For example, the feedback would be should add the login functions, because to prevent the piracy problem, should be the company's owner can only view their own the company's data. And actually at first we would like to add the login function, but however the AppSheet does not support these functions in the free version, so unfortunately we cannot add the login function. So after submitting, we will see the feedback will send to our email address, and we can view the feedback and try to improve our system. So this is the end of my part, and I would like to pass to my teammates on the web server of our system.
I'm Wantachi, and I will explain more on the web server part of this system. We cannot test all the things we make out, but I can show you how it works if I can test with a Arduino hardware right now. And here is the XAMPP control panel, which is used to create the web server, and I will start the web server right now. And if I call the admin, and the web page will show out, and just show the database out. And here, after we open the XAMPP control panel, and I can see that the phpMyAdmin is here, and I can create a database right now. And I will show the database I've created before. Here is the database I created, and which is called XD. And if I enter it, you can see that there is 4 columns, which is the ID, the humidity, the temperature, and the times when the database is recording. The ID will be increased one by one if there is more and more data is entered the database, and the humidity and the temperature is for the sensor to send the data here, and also the time is the time of the database the data is inserted into the database. And I can try that. If we want to edit this database, just insert the data into the database. We need the PHP file to input the variables into it. And because I can't change the screen, so I will show you how the PHP file will be entered right now. And here is the PHP file, which is called dict.php. This PHP file is for testing, just for testing. And if we enter the temperature and the humidity into the PHP file, push enter, and if we go back to the database here, and it will refresh, and you can see that the new data is entered here. And if we change the numbers, just like 20 and 60, refresh, enter again, and refresh it, the data is entered here. That's how the database works with using the PHP file. And next, I will explain more about the Arduino IDE, how the Arduino will be connected to the database system. And you can see that we have to include free library, which cannot include in the Tinkercad. This free file is not provided by the Tinkercad, and we cannot import this free file into the Tinkercad system because of some limitation of that website. And I will show you here how it will be linked. And first we will connect by the MAC address and just make some definition. And next we will connect to the Arduino with the baud rate. This is simple, and I believe that it will be connect success. And next we will receive the temperature and the humidity from the Arduino here, but using H and T, just two variables to save the data numbers. And when and the data numbers will be received and pushed into a data file, and will connect with my server with this IP address, which is my own IP address. And if it changes to other computer, it will be a different server address. And we will call the PHP file here, which is called add. I have three PHP file which is called connect, add, and index. This three PHP file is used to connect with the Arduino. The last PHP file you see, which is in the website, which called DHT, is just for a test. And if it is connect success, and all the data will be sent into the database system. And we cannot test it now because the Tinkercad is not available for this kind of service, and we don't have a Arduino right now, so this process is right here, and I believe that it will be a success because when we press verified, and there will be no error. And that's the end of this